Okay, so we're going to do a problem for what we call empirical formulas, okay, and percent composition. A neat way, and you're going to have to do 5 problems yourself on this too, but this is very easy compared to the equation writing. Very easy. It's recipe-like. Okay. Now I want you to look at the first video that I made on this, and you can see the recipe. I'll talk about the recipe. I'm not going to list it. I want to do a problem. And the way the problem I'm going to do, and it's going to help it make sense for you, because you can practice any problem you want, because you know nomenclature. For instance, let's do this. Let's say magnesium sulfate. What's the formula for magnesium sulfate? That's the formula for magnesium sulfate, okay? Now, that's actually an empirical formula. An empirical formula is a formula written with the lowest ratio combination of the elements involved. This is going to be 1, 1, 4. Isn't that lowest ratio of all the elements involved? Of course it is. Clear? Sodium chloride is 1 to 1, correct? Now when we do these, just keep thinking a mole is a number of particles. It's not a mass. It's a number of particles. If you said, it's the same thing as saying a dozen is 12. A dozen is simply a number of particles. A mole is just a lot larger than a dozen, but just remember that a mole is simply a number of particles, not a mass of something. Clear? Okay. Now, we're going to figure out the percent composition of this particle. So we're going to find the percent composition, excuse me, can you 3 stop whatever it is you're doing to distract each other and me? Me? No. Okay, thank you. Now, so the first thing you do is you find the total mass of the particle. Okay, this is 24. If you have I'll be your periodic table for you. Okay, this is 24. This is 32. And what's oxygen? Anybody remember? 16, right? What's 16 times 4?
64.
Who said that? Thank you, Pablo. 3 points for the Spanish team. Well done. Excellent. Now, so you have one magnesium that's 24, you have 1 that's 32, and you have 4 that's 64. So find the total mass of the particle, okay? What would that be? Well, 24, 32, 64. So what would that be? That would be 0, 3, 3, 6, 120, is that right? You want to check the math for me, please? 24 plus 32 plus 64, is that correct? Get out your calculator, thank you, Sarah. Now you want to check your math. It's important to be able to do math quickly, but you can always check with your calculator.
It's right.
It's correct, excellent. Now, look carefully. You see these masses? You see those masses? Do you see that? Do you see that this is the total mass of the magnesium? This is the total mass of the sulfur, and that's the total mass of the oxygen. Do you see that? Now, in order to find the percent composition, you put the total mass of the element over the total mass of the particle. The total mass of magnesium is 24 over 120 times 100. Because, why times 100? Because it's percent composition. That's magnesium. And sulfur would be 32 over what? 120 times 100. Somebody, Sarah, would you help me out? Somebody start doing these calculations so when I come back to them you can do that? And this will be oxygen, which will be 64 over 120.
MJ equals
20%.
20%?
Yeah.
Sulfur is what? They're doing the calculation. They're using a computer, handheld calculator, that has more power than the computer that was on Apollo 11
Oxygen.
that went to the moon. Yes, what is sulfur?
I have oxygen.
You have oxygen.
Oxygen 160/3.
Okay. I need a percent, can't be over 100, so it's 64 divided by 120. Anybody have that, Fabian?
It's 53.3.
53.3, is that what you said? So it's 53.3%. And what about sulfur? Yes, Sullivan.
26.6.
What is it?
26.6.
26.6. Connor Sullivan, excellent, well done. Okay, now, you may want to check to see if that's going to be approximately 100%. You know, you may have a little round-off error. So that's going to be, what? 46.6, 53.3, close enough. You have a little round-off error. Was that exactly 20 or was it something else?
That's 20.
It was 20? Okay, so there's round-off error somewhere. Okay, now, doesn't matter. Now, so that's the percent composition of each element. That's magnesium, that's sulfur, and that's oxygen. Clear? We're done. That is percent composition. You take a particle, you find the total atomic weight, atomic mass, and then you divide the total mass of the element divided by the total mass of the particle.
Is this finding how much percentage of one element is?
Correct. This is an elemental analysis, percent composition, however you want to phrase it. Clear? Yes, Fabiana.
So you would say there's more oxygen than other elements?
Yeah, by mass, this is mostly oxygen, by mass. So it's a lot of oxygen. So it's a nice source of oxygen, wouldn't it be, right? Okay. So I'm going to erase everything but this, those percentages. Now, we know that particle was magnesium sulfate, right? We know already what the empirical formula is given this elemental analysis. Wouldn't you say that's correct? Okay, now, let's work backwards. Now, let's say, and I will on quizzes, let's say I give you an elemental analysis in terms of percent composition, correct? Now, the first step is to assume you're using 100 grams. Now, there's obviously going to be some round-off error, but it's going to work off pretty well, okay? So, what you do is you work out of 100 grams, correct? So, you say to yourself, I have magnesium, I have 20 grams of magnesium, okay? You know, in other words, I have a sample where you have 20 grams of, or I can just say this, I have a sample with this elemental analysis, right? That's the problem. Clear? What you do is you assume it's 100 grams, and then say sulfur is going to be 26.6 grams. Oxygen is going to be 64, sorry. It's going to be 53.3 grams. Correct? Yes? Now, this is what you need. You can't compare the masses directly. The masses are not going to tell you what the combination of particles are. We know that magnesium sulfate is MgSO4. What's the ratio of magnesium to sulfur? 1 to 1, right? MgSO4, the relationship between magnesium and sulfur is 1 to 1, right? Okay. So 1 particle to 1 particle. So if we can't do masses, how are we going to relate the elements that are in this problem?
Moles?
Moles, because the mole is actually a count. It's a count. So you convert to moles. Okay, how do you convert to moles? Before I really tell you kind of a brain-dead equation, and I don't really want to treat you that way, let's use proportional relationships, because those never fail us. It's one of the best things you learn in math, correct? Now, we know that, what's the mass of 1 mole of magnesium?
6.
Where do you get 6?
It's
The mass? The mass in grams of 1 mole of any particle is equivalent to the mass of one particle in atomic mass units. What's the atomic mass of magnesium? I put it on the board. Where did I put it? I had it on the board before. What was it? 24 AMUs, right? It's right off your periodic table. So what's the mass of 1 mole of magnesium? 24 grams. So I know that it's going to be 1 over 24 grams, right? Equals, this is moles, equals X moles over 20 grams. So what does the moles equal? What is 1 times 20 divided by 24? 1 times 20 divided by 24. Or simply 20 divided by 24.
4.33.
What is it?
4.33.
No.
20
33?
Oh, never mind.
20 divided by 24?
Yeah, 20 divided by 24 is 0.83.
83. Okay, good. Is that right? 0.83?
Yeah, 0.83.
Okay. So what did you say? You said 0.33.
Oh, sorry, my bad.
That's okay. Okay, so that's 0.83 moles of magnesium. Are we all right with that? Yes? Can I erase this? Can I erase that? Is that okay? Okay, what are you doing? You're going the mass divided by the what? The what?
Mass.
The mass in grams.
Atomic mass.
So
Atomic mass, or we say the gram molecular weight, but we'll just say the atomic weight, okay? So what is 26.6 divided by 32? What does that equal?
0.83.
0.83. Well, yeah, round it up.
So, but it's close enough, right?
Yeah.
Yeah?
Yeah.
Okay. Is that exactly 0.83 there?
No,
No,
it's,
it's point-
Let's do 3 decimal places, and I'm going to tell you why later. Let's do 3 decimal places, okay? So what is 20 divided by 24 is what?
0.833.
Okay?
sulfur is 0.831.
831,
Yeah.
okay? And what is 53.3 divided by 16, right? What would it be?
16 or 64.
You're not using 64. Why would you use 64? Because in magnesium sulfate, there's 4 oxygens. That's not what we're doing. We're not doing percent composition. All I'm asking you to do, Fabiana, now don't get confused, all I'm asking you to do is convert that to moles. So you're going to divide by 16, right?
3.331.
3.331.
And it's going to be, what is it going to be?
3.331.
3.331.
Moles over what?
Over 1.
Of oxygen, right? Yes? Now, you see you have 3 values here, right? You have 3 values? Yes? You got to come up with ratios. If you have 2 elements, you only need really 1 ratio. If you have 3 values, 3 moles, you need 3 ratios, right? Correct? Okay. So it's always large over small. It's going to be large over medium, and it's going to be medium or middle over small. In other words, this is the largest value, this is the smallest value, and that's the middle value. Clear? So you come up with 3 ratios. Okay? So, what's going to be the largest over the small? What is 3.331? 3.331 moles over the smallest 0.831 moles. What's that going to be? Let me make sure I have enough board space here. What's that going to be?
3 decimal places?
Yeah, give me 3 Yeah, give me 3 decimal places. What is 3.331 divided by 0.831? Yes.
4.008.
4 let's put that in a different color. Can I erase anything? Can I erase some of that stuff up there? We get a little crowded, is that all right? Can I erase all of this? No, just this.
4.01 since we're doing 3 decimal places.
Okay, what are you saying?
It's 3 decimal places.
Okay, so it's going to be, so this is going to be L over S is going to be, what's the value going to be?
4.008.
4.008. And what about large over medium? What's that going to be? 3.331 divided by 0.833. What's it going to be? So it's going to be 3.331 over 0.833 moles, and what's that going to be?
3.998.
3.999?
998.
9, well, it's 9.
Well, round it off is
round it
999.
999?
Yeah, because it's 9987, so you just
Okay.
put 9.
Okay, and then medium over small is going to obviously be what? Close enough to what? Shall we do it? Okay. 0.833 over 0.831. Moles.
1.002.
1.002. Right? Now remember, is this close enough to round to 4? Is it? Yes, it's not. That's not close to 4. Come on, guys. 4.008, we can call it 4. Is 3 point? Can we round 3.5 to 4? No. But that is close enough to 4. Trust me. That's why you want to go out 3 decimal places. You want to make sure that the ratio is good. Now, we're going to have a little round-off error, but this problem is pretty straightforward. So can't you say that this is large, right? So that's oxygen over small, sulfur equals 4 to 1. Can't you say that? Right? Can't you say that this is going to be large over medium, oxygen over magnesium?
Also 4 to 1.
4 to 1. And magnesium over sulfur, can I round that to 1? Can I?
Yeah.
Yes? So this is going to be,
Magnesium to
medium is going to be,
magnesium
is going to equal 1 over 1. Clear? Now I'm going to erase everything except for the final answers. Is that okay? Okay. I'm going to erase everything. Is that all right? Okay, now you have to interpret the results. How do you interpret the results? Well, when you write formulas, where is the metal usually? On the left, the right, the middle, where?
Left.
It's always on the left. Where is oxygen normally?
On the right.
In the middle?
on the right.
Yeah, you think about it. Carbonate, phosphate, sulfate, nitrate, the oxygen is always on the right, correct? And then what would be in the middle?
What's left?
Carbon? Carbon would be in the middle?
No.
Did we use carbon? That's okay.
Salt.
Okay, now, what's the ratio of magnesium to sulfur?
1 to 1.
1 to 1, so that's okay, right? What's the ratio of oxygen to sulfur?
1 to
1 to
4.
4.
1 to 4. How about magnesium to oxygen?
1 to 4.
So if I go like that, I'm correct.
Yeah.
So given the data, the percent composition, right? Because I'm going to give you 2 kinds of problems and they're not going to be related. These are related because we simply took an empirical formula, did the percent composition, and then worked backwards.
Right.
Same process. And when I give you one, I'm going to give you one that works. Okay? Yes? You sure? Now, so this is going to be magnesium sulfate. MgSO4, the lowest ratio. Clear? Are we done?
I have a question.
Yes.
If it's easy enough to guess, can we skip the equations or?
You can do whatever you want, but you got to get the answer correct.
Okay.
Absolutely. What happens? Let's do this one. Let's do one more, and then we'll call it quits, okay? Is that all right? I want to show you one that's difficult. Write this down. P2O3. All right? Diphosphorus trioxide. I want you to right now do the percent composition. Phosphorus has a mass of, anybody?
31.
31, and oxygen is 16, right? So the first thing you're going to do, Ahmed, is find the total mass, right? So you want to get some paper out and let's get to work, right? Okay? I'll do it up here, and you do it by your place. Try to beat me. Try to get to the answer before me. I don't have a calculator with me. What do you think, I'm smart or something? All right, you get this? 110 is the total, yes?
Yes.
So 62 over 110 is what? What's 62 divided by 110? Yes. It's going to be a little over 50%. What is it going to be?
66.
Is it that much?
Yeah.
66%?
66% phosphorus and
It's not
34%.
66. Oh, yeah, but it's there.
62 divided by 110 times 100 is
No,
6.
it's not 66.
Okay, guys, I need you to use a calculator, and I want, let's say, 4 significant figures. Yes, Fabiana.
So it's 56.36.
56.36. 56.36%. Okay? So what's 48 divided by 110?
43.63.
Say that again, huh?
43.63. 64. Round it up.
0.64?
Can't
No,
round it
it's,
up like that.
why can't you round it up?
Because it's 6, it's not 9.
636.
It's 43.636. Yeah, it's rounded to 4.
Yeah.
You're rounding it to the hundredths place.
Yeah, but it's not.
Yeah, it is. You don't, yeah, it's fine. Okay, now, so that's percent, right? Yes, you got it? Easy? So far? I mean, easy, right? Is that hard? Anybody? Pablo, you with me? I'm not asking you to take a quiz right now. I'm simply asking this. Do you follow me?
Yes.
Okay? All right. So then, let's just do this. Right? Now, we're going to go backwards. We're going to say 56.36%, sorry, grams of what? Is that phosphorus or oxygen?
Phosphorus.
Phosphorus or oxygen?
Phosphorus.
Phosphorus. And then 43.64 grams of oxygen. Okay? Right? You're going to assume 100 grams of material. Right? All right? So change this to moles. So you're going to divide by 31. You're going to divide by 16. So what's that going to equal? How many moles? What is 56.36 divided by 31? Divided by 31.
1.82.
All right, do we have a verification on that?
Yeah, 1 point, yeah.
1.82? Is that right? Okay, now we got, I want 3 decimal places.
1.818.
1.818.
818.
Okay, 1.818 moles. Excellent. And what is 43.64 divided by 16? Yes?
It's 2.728.
2 point,
728.
Okay? Now, how many ratios do you have to make? How many ratios do you have to make? No, just one. You only have two.
Oh,
You only
yeah,
have two
right,
moles, right? Large over small, right? All right. So which one's larger?
Oxygen.
Okay. So you're going to go O over P equals 2.728, right? Moles, right? Can I write that a little clearer? 2.728 moles over what?
Over 1.818.
1.818. Can I erase everything but that? Is that okay?
Wait, Dios.
Okay. Easy, Enzo?
Yes.
Is that okay? Can I erase it now?
Yeah.
I just want to erase this. I just want to do this. Okay, now, what is, three decimal places, what is 2.728 moles divided by 1.818 moles?
1.500.
1.500. Okay, 1.500. Okay, where are you from? Santander. I like your accent. I sound Russian, but you sound Spanish. I like it. Okay? Okay. Now, so 1.500, and that's going to be oxygen over phosphorus.
3 over 2 over 1.
So I'm going to round that to 2 over 1. What do I do? I have 1.5 over 1. Now, what do? I round that to 2 over 1?
3
Or
over 2.
what is it?
3 over 2 over 1.
Whoa.
3 over 2.
3 over 2. That's right. Well done, Pablo and Mustafa. Excellent. 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 Well, because that's too
1.5.
large. You're like, that's 1.5 moles, really. It's like you're rounding off 1.5 moles. That's like an enormous amount. So if I double it, if I simply multiply by 2 over 2, because you see you need whole number ratios. That's the killer. That's the hard part. Right? That's the hard part, right? So this is going to be, I multiply by 2 over 2, and that's 3 over 2. So that's 3 oxygen for every phosphorus. So oxygen is usually on the right.
3 oxygen for every 2 phosphorus.
3 oxygen for every 2 phosphorus. So is this correct? Phosphorus on the left, oxygen on the right. Oxygen is usually always on the right, right? That's easy? Yeah? So what is the ratio? It's going to be 3 oxygen and 2 phosphorus. 3 oxygen and 2 phosphorus. And isn't that what I did? Isn't it? Okay. Yes? Cool. Are we there? Excellent. How many people strangely understand? Yeah. Good. Excellent. Yeah. And it's very cool.
Do we just like go around in a circle?
Yes. The circle is complete. Who said that? The circle is complete. I am now the master and you are the student, whatever he said. The circle is complete. Darth Vader, right?
Yeah.
Oh.
Somebody look that up. What was the actual quote? Somebody look it up on the thing. We need a Darth Vader quote to help us through the rest of this class. Okay?
Dude.
So, let me show you this. So 1.5 to 1, 1.33 to 1, 1.2 to 1. Those are going to be three examples that you're going to come up with. This is easy. 2 over 2. All right? If you come up with 1.5, you multiply by 2 over 2. This will be 3 over 3, and this will be what? 1.2.
5.
Multiply by 5 over 5? What about 4? What's 4? Let's not do 5 over 5.
4 makes it 4.8. Yeah, which is 12. Oh, 125. No, that changes it.
You get it? Do we have the Darth Vader quote yet?
I have it.
What is it?
The circle is not complete. When I left you, I was but the learner. Now I am the master.
The circle is complete. When I left you, I was but the learner. Now I am the master. I like
Who
that.
is he talking to?
So I think he's talking to Obi-Wan, right?
Probably.
Talking to Obi-Wan.
Oh.
Yes.
Yeah,
Yes.
it was Padawan.
His Padawan was like, yeah, Padawan. Very good, Enzo. I'm telling you, you're up on your Star Wars. I like it. Okay, so are we done? Are we off? Are we done? Yeah? So if you wind up with that, you see why you got to come out several, like 3 decimal places, because you got to make sure that you don't wind up with something like a 1.2. Then you're all, or 1.25. Because 1.25 is an actual, that's when you multiply through, you get 5 to 4. Is this right? Is that right? Is that right? Yeah, you see that? Sure. Pablo? Bien? Está bien, tío. No te enteres. Okay. You get it? Okay. We're off.